Good afternoon, all of you. I'm Prajakta. Today I'm represent on topic distance-based accident avoidance system using Arduino with CAN protocol. So these are the outlines. First of all, so let me move forward and start introduction. So current condition of road accident are increasing day by day. Cars on the same direction in highway usually keep a safer distance one another with a similar speed. However, due to a driver's distraction, long time driving, then flake out and even a sudden declaration of the previous car. A series of collision of accident may occur if a driver cannot be react in time to brake. On the other hand, a driver need to mirror to know the approaching car to uh, two sides or from the rear end. Even the driver check around carefully. He cannot take immediate respond except a push the horn to sudden approaching a car, and accident is thus unavoidable. Therefore, we developing this system. So these are the motivation. So we all know that accident rate in our country is very high. There are some reasons behind these accidents, such as drink and drive cases or due to overspeeding. Some reasons to that condition, system that would guide driver guide drivers immediate in dangerous situation when any obstacle like a human or vehicle and any other object come in front of the vehicle. This time speed control of the vehicle is the viable solution to avoid accident. Okay. Then these are the aim and objectives. Aim of the system to avoid. Yes, sir.
Continue.
Okay. Aim of the system to avoid a road accident by using ultrasonic sensor and speed sensor. Uh, then objective to design CAN-based accident avoidance system to set up ultrasonic sensor and speed sensor to implement control devices like Arduino R3 with many onboard interfaces to communicate through the devices to measure distance between two vehicles. So these are the problem statement. Uh, uh, Nowadays, so many accidents are happening in the India. The main causes of the accident include faster speed, obstacle, and careless driving. So next slide, hand over to Aishwarya.
Yes. This is a literature survey table. There are four fields: title of paper, description with seed idea, techniques, and merits and demerits. There are total 16 papers we refer for our project. Prajakta, next slide. This is the scope of our project. We can use this project for commercial cab companies. By using this system, they can get as per transport report as per their speed. And by using this system, cops can get fine directly from the cab company. By using this project, we can implement brake sensors to overcome this emergency. Next slide. This is preferred technology we used for a user interface. We are using GSM model. For a system interface, we are using ultrasonic and distance measure sensor, 16 by 2 LCD display, CAN protocol board, transmitter and receiver, speed sensor, alarm, Arduino R3. Next slide. This is system requirements. For hardware requirements, we are using Arduino R3, CAN board, DC motor, alarm, LCD display, power supply, ultrasonic and speed sensor, mobile, and GSM SIM. And for software requirement, we are using Arduino 1.8.10 software. Next slide is hand over to Nikhil. Thank you.
Okay, thank you very much, Aishwarya. So this is a system architecture of our project. So we have two modules in our project. One is a transmitter unit, second one is a receiver unit. So in transmitter unit, we use the sensors. All of the sensors are attached to the transmitter unit, and which can be transfer the data through the CAN board to the receiver unit of the CAN trans receiver we use over there. So in a receiver unit we have the one DC motor and one is alarm. It is just for the demo purpose, because we have created the one prototype also. And we can see a GSM module in the receiver unit. This module is used for the sending the SMS to the owner of the vehicle and the cop stations for the whatever the situation at that time. For communication purpose, we use the GSM SIM module over there. Next slide. Okay, so probable solution, we are using it one transmitter and one receiver part, as I said earlier. So transmitter can consist of all the sensors and speed sensors like Arduino and speed sensors, CAN board, CAN trans receivers, and power supply, one LCD display for the testing purpose also. And the receiver part, we have DC motors, GSM modules, and one buzzer alarm, which is comes under the government norms for the each and every vehicles. Next. Okay, so this is a module description. One, we use the transmitter module and receiver module. Next slide. So this is a DFD one level one diagram. So basically we have a running vehicle which will attach with the two sensors like ultrasonic sensors for the measuring the distance, and second one is a speed sensors which continuously calculating the speed of the vehicle in a loop. It will send the data to the CAN sender and receiver, which we can see the receiver module. And from this it can send to the Arduino of the receiver module, and from the Arduino, which is a microcontroller, which send the data to the GSM module if the condition will be satisfied. If the condition is satisfied, it will send to the message to the GSM module, and GSM module will send message to the user that your speed is under not under control, or you can exceeding the speed limit of your vehicle. So this is a UML diagram. Just next slide. Okay, so this is the active okay, so this is the activity diagram, what the activity actually perform. So we have one target of the vehicle. So these are the two sensors basically, and there will be check the condition on the ultrasonic sensor whether the obstacle is present or not. It continuously checking the with using the frequency of the 40 megahertz continuously, because it is a very important to check repeatedly the using this frequency, because if you calculate the once the frequency and after that it will not calculate the frequency, then the project will be terminated over there. So that's why it will check continuously. If the obstacle is present, then reduce the speed and maintain the distance. The message will be display on the dashboard of the vehicle. And second one is, if not obstacle is not present, it will move to the target, means it will continually running without any buzzer or any message sent to the users. So second is a speed sensor. It will check the condition whether the speed of the vehicle is appropriate approximately, or it will be increasing or decreasing. As per that, it will check whether the speed is increasing, alarm will on, receiver unit send the message to the GSM module, and it will send to the users and road transportation police also, that this particular vehicle is over speeding. You can convert it to the government challan also, or you can create the challan of this particular vehicle with the vehicle number. And second, if the speed limit is below the speed limit, so it will move to the target. So it will be continuously in looping format. Second diagram. Okay, so this is a class diagram, whatever we actually objects are used over there. Next. Okay, so this is a sequence diagram, what actually happen in a sequence manner. So vehicle and users are both are the two objects we use. These continuously running, vehicle is driven by the driver, and the sensors are continuously getting the data and send it to a Arduino of the sender, and from the Arduino microcontroller it will send to the receiver module, and from the receiver module it will send to the Arduino receiver module, and it will send to the GSM module. It will be continuously in a looping format, how much time the vehicle is on or we are traveling on the highways or any roads. Next. Okay, so this is a grand chart. Next. Okay, so this is an experimental result. What we actually did. So this is a transmitter module. Here you can see one speed sensors, one ultrasonic sensors over here, one display module, one power supply, and one CAN board of the transmitter module. Next. Okay, so this is a receiver module. Here you can see the motor also, which is actual engine of the vehicle, but this is a prototype, so we use the DC motor over here. Second one is a buzzer. You can see here, and on the right bottom you can see the CAN receiver module. Next. Okay, so this is a speed sensor we actually use. Next. This is a ultrasonic sensor. This is a power supply. This is a CAN trans receiver module. This is Arduino Uno R3. Okay, so this is 16:2 LCD display, which we use for the testing for the both transmitter and receiver unit, whether the data comes from the sensors are correct or not. For that purpose, we use the two LCD displays. So whenever the condition satisfied, as I said earlier, there is a verse. As I said earlier, there is a condition for the speed sensors also. If the speed is increasing the limits, then it will send the message to the users also, and also the same message sent to the cops or road transportation public services also, with the vehicle number in the text normal format. Next. Okay, so basically we have concluded finally this project intent for the security and smooth journey of the each and every citizens of India and in the world. The car of the vehicle itself is aware of its movement, because in the latest technology we know that there is a lots of sensors comes under the government norms. We have EBS, ABD, parking assist sensors, lane assist sensors. We are okay. If the driver himself is not concentrating on driving or any other parameter which may cause a damage to the vehicle as well as the life also, so vehicle will warn to a driver regarding the danger ahead. That's where that should we conclude over here. So next slide. Okay, these are the references. We have 16 papers read. Okay, so thank you very much. If you have any question, please ask.
Hi, Nikhil.
Hi, ma'am.
It's a good project with a good title. And
Yes.
Have you done this project practically?
Yes, ma'am. We have done it practically. Yes, and it is 100% successfully done.
Yes, because until and unless you are not doing the project, each and every sensor
Yes.
name you cannot remember. Okay.
Yes.
After that, which language we are using in
Embedded
software?
C. Embedded C we have used.
Okay.
Okay.
Okay. Thank you.
Thank you.
Thank you, ma'am.